So why is attention so limited? Aha, I knew you'd be asking. It's because of short-term or working memory. Now, some information processing theorists will pull these two terms apart and talk about short-term memory and working memory. The vast majority keep them together in one term. They call it short-term memory or short-term working memory. Let's look at computers and people again here for a minute. Now, computers have made huge strides in their working memory capacity. The first computer that I learned on was a Commodore 64, which had 64 kilobytes of working memory, which means that I don't think you could have typed a sentence on it in Current Word. I don't think you could load, I know you couldn't load Current Word because it takes like over a megabyte. But you could type on those. Okay, when I first came to UGA in 1994, I got a state-of-the-art laptop, pictured something very like the one pictured here. It had 500 megabytes of memory. By the way, 64 kilobytes means 64,000 bytes, and each byte has 8 bits of information in it. So that's really quite a bit when you think about it. 64,000 bytes of information all at once. That Commodore, that primitive old Commodore, could handle all at once. My computer in 1994 could handle 500,000 bytes of information. 500 million bytes of information. Megabytes. And again, every byte has 8 bits, except if you're working on a 16 or a 32-bit computer, but in those days they weren't. Now, the current computer I'm working on right now has 8 gigabytes of working memory. We're not talking hard drive, we're not talking storage, we're talking working memory. It can handle 8,000 million bytes of information all at once in its working memory. People, on the other hand, are severely limited. We can handle 5 to 9 bits, not bytes, bits of information at once in our working memory. Not 5 to 9 megabytes, not 5 to 9 gigabytes for sure, not 5 to 9 kilobytes, 5 to 9 bits of information. And this is a figure that has been tested over and over and over and over. And it's around 7, like your book says, you know, and plus or minus 2, average. So this gives us a problem. In short-term working memory, information processing scientists have identified, and remember, these are not brain structures, this is a model, have identified several parts, so to speak. There's the central executive, which is the working memory, and there seem to be 2 subroutines or subcomponents. One is the phonological loop, which you use to work with sounds. So if you've ever recalled something by sound, if you're learning a language and you, for example, if you're learning French and you learn that the town of Des Moines should not really be pronounced Des Moines at all, it should be pronounced Des Moines, okay? That's the phonological loop that you're working with there. The visuospatial sketchpad, which by the way requires a lot of your phonological loop to pronounce, the visuospatial sketchpad is the thing where you remember visions of things. This is where you work with people's faces, for example. Now, this is not where you store your memories. Please help me. I want to be very clear here. This is where you bring it up and you do the comparing in your head. You look and you say, ah, I have a memory in my long-term memory that this is what this person looks like, and I am now looking at them and I compare the two, and yes, that's who that is. Okay? So we have some problems because of our working memory having so many limitations. One of the limitations is it's very short. Short-term working memory, we're talking very short term. We're talking 5 to 20 seconds. It is a little bit longer than a computer, but not much. And if you've ever worked with one of the old computers that didn't autosave, You know about this problem. And it happened to me on the first computer that I was writing a book on. I was typing away madly and of course did not save because you didn't have autosave as often as I should have. And the power went down and everything I was working on disappeared. It didn't sit in that short-term working memory until I could get the power back up. No, it left. That's what happens to our short-term working memory too. If you are working on something on your little mental desktop and somebody interrupts you, whatever you were working on isn't there anymore when you go back. And if you've ever had it happen, now it doesn't happen so much now because of cell phones, but if you've ever had it happen where you had to look up a phone number one place and then you had to go somewhere to call it, so you're walking maybe to another room in the house and you're going, what are you doing? You're doing something we call rehearsal, which keeps something from decaying in your short-term memory. It's just like hitting the refresh button on your computer, which, by the way, your computer does constantly. So you're walking from one room to another and you're going 706-542-6927, 706-542-6927. And what happens if your significant other interrupts you at that moment and says, honey, where did you put the... By gum, you don't have the number anymore, do you? You have to go look it up again, don't you? The other problem that we already discussed is our short-term working memory is very small. It varies, by the way, with age and condition, okay? So if you are young, little children only have maybe 2 or 3 bits in there, which is why you can't tell small children to clean their room and then go take out the garbage and then let the dog out and then, because they can't remember all that. It's not there anymore. Even for 2 seconds they can't remember it because they don't have that many bits in there. Okay? It also varies with your condition. If you're sick, as I have been recently, you can't think. Remember, do you know how that feels? You think, oh, what was I thinking? That's because your working memory is going down. Okay? If you, I'm sure none of you, have ever had too much to drink, the same thing happens, by the way. Your working memory just really goes down, which is why, by the way, it's a very bad idea to drive. Okay? And anyway, and some people hypothesize that people who are more intelligent have larger working memories, which again is drawing that parallel to computers. The larger a working memory a computer have, the smarter, quote unquote, the computer is and acts. And some people hypothesize that this is one of the basic reasons for differences in intelligence. Okay, so if our short-term working memory is so short and so small, cognitive overload is a constant problem for us. If we only have 5 to 9 bits, how do we deal with the fact that most of our life requires us to remember more than 5 to 9 things at a time? I mean, you have to read a sentence longer than 9 words, there you go, down the tubes. No, you don't. And the way that we do it is a number of important things. And I don't have them in the right order here. What I want to talk about first is automaticity. Thank God for automaticity. Did you know that when you walk, you have to move over 100 muscles, all in exactly the right order? And if you have ever worked with somebody who became unable to walk from a stroke or something and had to learn how to walk again, they have that problem. They actually have to learn to move all those muscles. If you've ever watched a little child learning how to walk, they're thinking so hard about how to do it. They're thinking and thinking, and if you talk to them or you say something to them or they notice something, what happens? They fall down because they can't think about walking anymore. Now when you and I walk, we don't have to do that. We can walk and talk and chew gum all at the same time because we've automatized our walking. We're not using any working memory to do that. Another really good example of this is driving. Do you remember when you first learned how to drive? Could you talk to anybody while you were driving? Could you have somebody talking to you? No, you couldn't. You had to think about every move. Now I have to do this. I have to put the shift bar here. I have to use my foot on the brake. I have to turn the wheel. Now you're fine. You can have the radio going. You can have a conversation going. Some people even text while driving, which is really a bad plan. But that's mostly because your eyes can't see the road. It's not because your brain is being used that hard. Basically, you're automatized when you drive. Have you ever set off driving for one place and found yourself going someplace else? That happens to me. That's because of automatization too. Automatization has its downsides. Because if you're working on automatic, you're not able to take account of changing conditions. And in fact, a lot of accidents happen because people are driving on automatic, which they can't help doing. They've automatized it, and something happens and they don't snap out of automatization quickly enough to change what they're doing. Another thing that we do is we forget things. We have interference. If you're doing one thing and something more important comes along, if you're sitting outside your cave as a caveman drowsing in the sun thinking about how cool the rocks look, and all of a sudden there's a saber-toothed tiger there, guess what? You've forgotten about the rocks. We get interference. The more important, the more urgent thing takes over our short-term memory. And the last thing we do, which is brilliant of us, is we do something called chunking. In other words, we take a bunch of little bits of information and we ball them up together into one bit, and that's all we have to work with. And I'm going to give you an example right now of chunking. Okay? Here's the example. I'm going to flash on the screen a set of 10 letters, and I want you to look at them for the few seconds they're on the screen and memorize as many as you can and try to say them. Here they come. Okay, they're gone. See how many you can say. If you are like most people, you got somewhere between 5 and 9 of them. Not all 10. Very few people get all 10. Okay, now I'm going to show you the exact same letters, but they're going to be organized a little differently, and let's see if you can do better this time. Okay, now repeat them. You didn't have any trouble, did you? That's because you weren't remembering every single letter. You weren't trying to keep all 10 letters in your short-term memory. What you were doing was you had stuck one thing in your short-term memory, and that was alphabet, A to J. Notice it was your long-term knowledge that allowed you to chunk. That's one reason that people become much more efficient thinkers the more they know, because it's your long-term knowledge that lets you put things in these little packages to chunk. The last thing I want to say about automaticity is how absolutely vital it is to reading. You are no longer capable of looking at the average word and not reading it. Your reading is completely automatized. When you're reading something, you don't have to use your short-term working memory, your precious 5 to 9 bits, to sound out the words or identify the letters or anything like that. You're not even thinking about the reading. You're thinking about comprehending the message. And when little children are learning how to read, or adults for that matter, when anybody's learning how to read, at first they spend all their 5 to 9 bits trying to decode the words, and that's why they often seem to not be very good at comprehension. Whereas most of the time, the problem is they're glitched on the decoding. Now later, after they figure out the decoding, there can be comprehension problems too, and we're going to talk about them when we talk about long-term memory. Okay? Okay, so last thing I want to say in part 1 here is that short-term working memory is very limited in isolation. And you should stop watching now. This is the end of part 1, and turn to the video about Clive Wearing, who is a man. In the video it says that he doesn't have any short-term memory, but this is a lie. They don't know what they're talking about. What he is really is a person who cannot move things from his short-term memory to his long-term memory. In other words, everything that is in short-term memory, and when the short-term memory, that few seconds, that 20, 30, 40 seconds goes, when something else, it's gone. So I think you'll find it kind of interesting.